sun is shining 24/7.
Mint Home is a tool which allows users to control household devices with their mind. This is geared toward the disabled, who will be able to control devices like a TV just by thinking. Our design is based on the fact that humans produce different brainwave or EEG signal patterns when thinking of different things. By recording the EEG signals of the users while they are thinking according to the stimuli on the app screen, we can label the EEG data and train a machine learning model to classify those EEG patterns, which are then translated into commands to control devices that are wirelessly connected to Mint Home app. We collected the EEG signal using OpenBCI Cyton board and Gold Cup paste EEG electrodes.
Our web application guides the user through the setup steps. First, the user is prompted to connect the EEG headset or board. Second, they connect their Mint Home device. The device we'll use for this demo is the TV controller, which can turn on and off a TV and change the channel. The app connects to the device via Bluetooth.
After they're connected, the headset EEG data can be seen on the data visualization page. Once they're all set up, the EEG data that's being read from the user is sent to the machine learning model, which will decipher when the user wants to send a signal to their TV.
The correlation in between the app and neural net needed an accurate and precise delivery mechanism. The method involved 10 or 18 electrodes connected according to the 10-10 EEG spacing system, which lowers the variance in the signal data and offers more precise predictions. The data collection process was designed to minimize environmental noise and maintain consistent readings. Data is always collected in a room within 20 to 30 decibel ambient noise levels, in the late afternoon when neural activity levels are high.
The data is recorded simultaneously with the participant watching a video of visual cues. The participant is asked to imagine moving a specific limb at these timed cues. We also purposefully collect specific noise samples. This includes measuring the EEG signals of actual movements in various considered muscle groups, as well as purposeful noise collection from eye movements, which might disrupt the signals produced by the brain.
Finally, post-processing filtering methods include linear time filtering, baseline correction, and amplitude averaging. We will now explain further in depth specifically related filtering methods. Moving average filter is optimal for common problem, reducing random noise while keeping the sharpest step response. It decreases the amplitude of a random noise, but also reduces the sharpness of the edge. Digital filtering techniques are commonly applied to time domain signals. They also can convert a time domain signal to the frequency signal and convert back in a very short amount of time.
To train our classifier, we used a database of motion intent data, that is, EEG data in multiple channels from a person imagining left or right hand movements. Pictured here as an example are 3 such channels for a sample left and right hand motion intent. We take data like this and decompose it into a discrete Fourier transform for each channel, which is then taken as the input to our classifier model.
The model itself contains an attention module and 3 regular fully connected layers. The attention module works intuitively by bringing the model's focus to both specific frequencies and specific channels in the data that are more discriminative to the final output. The fully connected layers simply act as a trainable and complex function that maps the frequency data to the final output. After proper training and testing, the model can be used to grab data, obtain an output prediction, and pass all of this information to the rest of the app.
This is a remote control. It contains an Arduino Uno, an HM10 Bluetooth module, and an infrared LED. The Bluetooth module receives a Bluetooth signal from the desktop app Mint Smart Home. The remote then interprets the signal and sends a corresponding infrared signal to the TV. Currently, it can turn the TV on and off and switch channels. Eventually, we hope to implement a function so that it can also change the volume.
Due to COVID restrictions, we have not been able to collect enough data to train the model effectively. Thus, we have used the online EEG database and made a virtual simulator to show this demo instead of a real user wearing an EEG headset. For future rounds, our goal is to have the app work with a real EEG headset and add functionality to the web application. With applications like Mint Home, an entirely new way to interact with technology is born. Applications like Mint Home are the future, and we hope to build it as soon as possible.
With you, the sun is shining 24/7. 'Cause when we're together, it feels like we're in heaven. If it will get dark, you'll be my million stars.